All right. I guess you all know who I am. I'm Kim Stedman. I work at JPL. I have too many job titles to actually remember them right now, but I work on Perseverance and Ingenuity. And I have 5 million slides, and I apologize ahead of time. And I'm very tired, and let's see how this goes. So, first of all, Perseverance is a rover that's going to Mars. It's there now. And here are our science goals. We're going to study ancient microbial life, and I'm very happy I said that correctly. So we're going to look at geology, astrobiology. Oh, and by the way, we're collecting samples for return to Earth, and we're preparing to send humans to Mars. I will talk about that in just a second. So here's our wonderful, beautiful rover and all her science instruments. And the way that we're preparing for humans to go to Mars, one of the ways is we have our MOXIE instrument. MOXIE is like the oxygenator from the Martian. MOXIE breathes in the atmosphere from Mars and then makes oxygen. And we're going to need the oxygen to bring our astronauts back and to give them something to breathe while they're there. And our other instruments, at the end of the arm, we have Sherlock and Pixel, which we're going to put their proximity science instruments.
Why is Sherlock important, Kim?
Sherlock is important because I work on Sherlock. And because it's really cool. It's a Raman spectrometer. It's the first time we've seen one of those there. And it also, Sherlock has Watson, which is a refly of the MAHLI instrument from Curiosity. And MAHLI is Mars Hand Lens Imager. Watson is an acronym that I don't acknowledge. Because I can't remember it. But anyway. So Watson is our imager, and Sherlock is the spectrometer. We also have an X-ray spectrometer, which is Pixel on the end of the arm, along with our drill. Then we have our weather station Meta, SuperCam, which is the next generation of ChemCam from Curiosity. And it's super because it has 2 different lasers and a microphone, which is all kinds of fun. And then we have Mastcam Z, the Z is for zoom. And so this is our spectacular imager, which also makes great videos of helicopters when they fly on Mars. And REMFAX is our radar that looks into the ground and tells us what's down there. They're mainly looking for water and all kind of stuff like that. So I think that's everybody. So we also have engineering cameras. And the last talk I did, someone who works for the engineering cameras is actually here, and she's like, you didn't talk about eCam. Okay, I'm talking about eCam now. So eCam, we have 2 Navcams, Navcam left, Navcam right. We have our front Hazcams and rear Hazcams. The front and rear Hazcams, we use them every time we drive the rover to make sure that at the end of our drive, our wheels are firmly on the surface of Mars and aren't up on a rock and or anything like that. Because if we're perched on a rock, even a small rock, and we unstow our gigantic arm and the rock, we fall off the rock, then we're going to smash these wonderful sensitive science instruments into Mars, and that would not work very well. So this is the most cameras we've ever put onto a rover. And so if you're looking for ancient microbial life, where would you send your rover? Well, Delta is where we find lots of life here, so that's where we sent our rover. To Jezero crater, which is just beautiful. Look at that delta. So we all know that 2020 was a weird year. 2020 was the year that the whole entire Mars 2020 team was supposed to go to Florida and watch our spacecraft launch exactly on time. Well, we all watched from our homes in California as our spacecraft got sent into space, probably about 2 weeks late because everything was late in 2020. And so here we are in a beautiful, beautiful Florida day, sending ourselves into the sky. About 5 minutes before launch, earthquake hit California. And as we were all sitting in our homes, and it was really early in the morning too, we thought, no, we've overcome so much. No, because if JPL loses power, we don't launch because we can't confirm that the spacecraft is safe. But it turned out to be a very small one, just enough to get our attention. And so we would know that 2020 was not done with us yet. But we launched. We were all, well, I was relieved because, I mean, sitting on that fire, no, I was afraid. And so for the first time, we had all these cameras on the sky crane, on the rover. And so this is the first time we were ever able to see our entry, descent, and landing run from end to end, because we can only test pieces and parts of it out here on Earth. We can't do what we call an end-to-end test. But I'll let Swati tell you about it.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Click indicate chute deploy.
The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration. in the velocity. Our current velocity is 480 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yeah, you can actually see the heat shield impact. Somebody on Twitter blew that up, and it looks really great. And I don't know how Swati could keep speaking during this.
Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OBS valid.
We have confirmation that the lander vision system has produced a valid solution as part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here in safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
It's crazy.
Moving signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin taking the stand of pathway. We are starting.
We're not going to do that again, but I will tell you that I was not aware of the fact that we had these cameras, and because I was too busy doing my job, and we were so siloed because of COVID. And so the first few days we're on Mars, of course, every time you get data, you don't know what you're going to get because we have so much data from entry, descent, and landing. And so as the images come down, you just pull them up on your computer and you look at them, and a lot of times we'll get the thumbnails first, which is a little tiny thing, and you can't always tell exactly what it is. And I saw this thumbnail, I'm like, what is that? It's not Mars, what? And then it dawned on me, it's the sky crane. And I thought, oh my God, there's a video. Oh, this is going to be great. And the day we got the video down, I'd called into a process called campaign implementation. And I was at home because when I do my Sherlock job, I work at home. And when I do my uplink lead job, I actually go into JPL. And so we were on the WebEx, which is like the Zoom. And we could see the room at JPL where the people that were there. And there's this, you can tell this one guy, Raymond, is looking at the screen. And he does this. And so someone that's also remote says, we're going to start the meeting soon. I said, well, you have to give Raymond time. He just saw the sky crane video, apparently. So, and here's our parachute. We were told in no uncertain terms that we were not to put JPL anywhere on our rover. So we didn't. We didn't even put it on the parachute. We put dare mighty things and then the coordinates for JPL. Totally innocent. And we got an image like this for our curiosity. And this is the high-rise imager on the Mars Reconnaissance Orbiter spacecraft. So not only was, you heard Swati say that the MRO data was flowing. So during landing, we lost touch with MRO. So for a while, for a few minutes, it seemed like an eternity to me, we didn't get any data. And then in the clip there, they called it the MRO's back. So MRO was sending us all of our data from landing, and they were also taking this fantastic picture. So MRO people are wonderful. Here's our first image from the surface. This is one of the Hazcams. Our Hazcams actually take color images, unlike the Curiosity rover, whose Hazcams takes only black and white. And then our landing area was, of course, named after Octavia E. Butler. So I was very excited when I found that out. And there's our little green dot. That's where we landed. So during landing, I was actually in the room with the same Raymond I was just talking about. And he's a PhD scientist, and he's on the science operations team. And we landed, and then everybody in the room, there's only like 6 of us, okay? But we're yelling, image, 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 and we got the image. And then Raymond's like, I don't care about your image. Where are we? and then they showed, I don't know if you've seen it, I don't have a copy of it, but it's a map of Jezero crater, and it has green and red splotches on it. And there's a lot of red splotches. And another person that was with me, James Hazelrig, was like, what is that? I said, oh, well, the red is where it's dangerous for the rover to land, and the green is where it's safe. And he's like, good Lord, I'm glad I didn't see that before landing. So, and of course, when you land, you want to make sure that the biggest concern is we've put our poor rover on this launch vehicle that just shook it vigorously. And now we've landed on Mars with these rocket engines, and so we want to make sure our rover is still healthy and safe. And so one of the first things we did was take a Navcam panorama of our deck. And so you can see the pixel instrument right there. It's the big white thing with looks like a laser on it. And so for those of us who've been working on Curiosity for years, we're like, the rover's really white because Curiosity is very dirty. And so, and we were also happy to see that there was less dust and rocks up on the deck than when Curiosity landed, and that was just luck. So there's lots of Easter eggs on our rover, and here's another one of them, and we just showed you the deck, and so this is a plate that is on the deck, and this is our rover family portrait. And I'm not sure why they chose to unstow the arm for Perseverance, but I guess to make it different from Curiosity, even though they both have arms. But you can also tell the first one's Perseverance because it has the little Ingenuity, the helicopter, with it. And so this is adorable. I don't have this shirt on, but they made a shirt. Everybody's making these shirts. They're amazing. And here's our first Mastcam Z 360 panorama. Mastcam Z, the images that we get from Mastcam Z are just incredible. And the skill of the people operating that instrument are just amazing. So here's another Easter egg. So if you sent your name to Mars, there it is, right above where it says NASA JPL. Not that you can see that. But, so that's the back of the rover with the RTG with its fins, and to the left is the UHF antenna. And so here's the little plate, what it actually looks like. And so they put how many people, like, 10.9 million people, and then the sun rays have some hidden Morse code. Again, we like these things. But this time it just says Explorers 1. It doesn't say JPL is great or anything like that. Even though we are.
Yeah, is that also where the names of the students that submitted essays, are they included?
I think the actual essays are there too.
Is it?
Mm-hmm.
Okay.
And so then the next thing, because we've landed on Mars, and now we've got to start unpacking and checking everything, make sure everything works. So the first thing we do for the wheels is to make sure that we can move all the wheels, and so we did what's called wheel wiggles. And they just cracked me up. And you can see that the one to the right actually pushed a little rock out of the way when we did the wheel wiggle. So we have to make sure everything works, and then we did our first drive. It was not a spectacular drive. It was just, forward a little bit and turn around and see where you came from. But it did prove that the mobility system had survived and that we were really happy. So if you can look ahead of the rover and to the right, and you see the light-colored area, that's the scour mark from the landing engines. And if you see a lot of the images of the helicopter, you can see the scour marks in it because we drove all over the place to do some other stuff, and then we ended up dropping Ingenuity off almost exactly where we landed because it was a really good area for her. And before landing, they were worried that it would take us months to find an appropriate flight zone for the helicopter. And we're like, nah, we're right here, let's do it. So and then we also had to practice. We were testing the instruments to make sure they still worked, but we're also letting the instrument teams, the scientists, get used to working with each other. And so for like SuperCam, you need the Navcam for the greater context of where the rover is, the mass cam for the up close of the rock, and then SuperCam can do its little RMI mosaic. And so we have to have all these, and then we have to also make sure that there's information on each of these images so that 10 years from now, if a scientist says they want to look at this Yigo rock, they can find all of these images together very easily. And then we unstowed the arm. Not very exciting, but there's the turret moving, the arm's unstowing, and we were excited because that meant that arm science was soon to come. But it also meant that there was another Easter egg. So there's these protective covers, plates on the arm, and they actually say Mars 2020, and they have our symbol. But if you look to the right of 2020, you see this small, tiny text going up and down. That's our vehicle identification number. And so it's got all this information. We are Rover. Let's see, what powers us? We're electric. Oh, and we also have a helicopter, so we're REH. The location of operations, Mars. Objective, exploration. And so, yeah, so mission, operator, plant, that's one, NASA. And we're also the 5th rover to land, so yeah, 5th successfully landed Mars rover. And so I was like, why, I missed one. Oh, poor Pathfinder, I forgot you. So anyway, so yeah, somebody went through all this trouble to get this on there, and they also worked with the automotive people who assigned numbers to vehicles and stuff. The Society of Automotive Engineers also got to put some stuff in there. So, and then we have to drop stuff off because we like to litter Mars, and we also, it's not our fault, we have to protect our rover during landing, and so the first thing we did was drop the belly pan. A belly pan, you ask, what the heck do you have that for? So here, if you were underneath the rover and looking up into the rover, here's our sample handling assembly. And so that is where we're going to, when we take samples, we're going to pull them in, and there's an arm in there that's going to go get the sample tube and feed it up into the drill, and then when the drill comes back, it's going to take that sample tube, it's going to move it over, it's going to image it, and then it's going to seal that sample tube, and then it's going to put it over here so that later on we can drop it on Mars. But the arm that moves the sample tube around, the elbow swings down below the deck of the rover. So we actually have this gaping hole in the bottom of our rover. But we can't land that way because all that dust and dirt from the Mars landing engines will get up in here and damage everything. So that's why we had the belly pan. So we dropped it off so that we could sometime do our sampling stuff. And the helicopter, which was just strapped to the bottom of the rover, that was a choice. I was like, you're just really going to strap to the bottom of the rover? Worked quite well. So they gave it a debris shield so that the helicopter would not get damaged. So of course we have to drop that before we can drop Ingenuity. And then it took us about 6 sols to drop Ingenuity because every step of the way, every command, release launch lock. We command that, and then we image with the Watson camera that's at the end of the arm. And then we have to have ground in the loop. We confirm that happened, and then we do the next step. Swing down. Confirm. Push to hard stop. Confirm. Release the legs. Confirm. Then you hit the point of no return because she has batteries on her, and while she was attached to the rover, we can only charge them up to 33%. Once they were charged to 100%, within 24 hours you had to drop the helicopter. If anything went wrong, doesn't matter. You have to drop the helicopter and drive off. So that's what we did. We dropped her, we drove straight off of her, and it worked quite well. We did have ground in the loop. We had a high gain antenna pass, and so we could confirm that she was no longer connected to the rover, and that the rover thought she dropped her. And so we said, okay, let the drive happen. Then we drove off, and then only once we turned around and imaged the helicopter did we know she was actually really safe. And there she is. And who was the uplink lead for this day, you ask? That was me. I dropped a helicopter on Mars, and I may never get over it. And then, of course, we took a selfie. And you would think that we're all smart people, and we had planned for years to take this selfie. That is, in fact, not how it happened. We got close to dropping the helicopter off, and it was in the plan, for the upcoming Sol path, and we knew we were going to do it. And then I got an email one day inviting me to a meeting, and the name of the meeting was Selfie. And I thought, that's a really early meeting. I'm working really late. I'm going to that meeting anyway. And so, yeah, it was just a meeting where we all got together, a small team of us, and designed the selfie. And I built a plan and to prove that we could do it in the power constraints that we were given during this part of the mission. And weirdly, it went in the plan, and the first time it actually faulted. We're like, we're not going to get another shot. We're not going to get another shot. And then they're like, no, do it. And so it took us 2 days to actually get it done. But it's beautiful. It's hanging on my wall. And so here is our first flight. If I can get it to play. Please play. All right. That is not working. Oh, there it goes. There it goes. There, see them spinning? So this is from Hazcam Z. They shot, the flight is very, very short, as you'll see, because you'll see the entire flight. But they filmed for half an hour because they didn't know exactly when it was going to happen. And for the press release, they had to figure out what 2 minutes we could download, because it's high res and we couldn't get much down before the first press conference. And they pegged it. They're magicians. It's mainland space science. Yeah. So that doesn't look like much, but that was huge. And then, this is my favorite. So yeah, this is from the Peanuts folks. And when I saw that, I'm like, oh, I love Snoopy. I was so happy. So, and here's another one. Let's see if I can get this to start. So the first flight was just straight up and down, but that's kind of boring. So we proved we did that. And then, then we go up and out. So she doesn't go very high up. It's only about 15 feet up. It is crazy. It's absolutely, not only that we could do it, that we can video it. It's crazy. Yeah. Yeah, I don't think they had any idea that, I mean, they knew we would try and get it, and it was ridiculously complicated. And sometime the rovers or the helicopter will come back. There it comes. So the first 4 flights left from the same place that they returned. And then after that, we started spelunking along. Because staying in the same place is not interesting. So it was a technology demonstration, and they had demonstrated everything they needed to demonstrate. And so after a couple of flights, they have a navigation camera just like the Rover does, and it takes black and white images, and it's just used for while the helicopter's flying along, it's looking down and taking images and figuring out where it is. But it also has a science camera, which is really a cell phone camera. And so they take science images too. And so this is one that caught the Rover. And so this is the first time that we've been actually photographed from that close when we didn't do it. And MRO got us, of course, and MRO can, when they go over, they can see the little tiny Rover, but this was spectacular. We saw, and a guy at work, Matt Linda, he's like, did you see the Ingenuity images? And we're like, yeah, they look good. He's like, did you see the Rover? And we were outside eating lunch, and he's like, did you see the Rover in the images? He just turned around and left. And as we're all like, where? Okay, so I think then the description of this panel was a discussion of Mars time. So I know that every time I've ever talked about this mission, everybody asks me about Mars time and how you handle Mars time, and I'm like, I don't know. I have skillfully avoided Mars time for my entire career. Until now. And so here is landing day. I was one of the few people that got to actually go into work, and we had a little assigned uniform. We had a little shirt. We had a little mask that I'm not wearing today, but I've been wearing it this weekend. And I augmented it. The same person that made the umbrella, they made landing socks. It's sciencesocks.com, so I bought landing socks. And then I looked on Twitter, and I was going to post my kit. And I noticed like at least a dozen other team members also had the same socks. And so we were just giddy. And so we all had our landing socks. And there's I took a screen picture of my screen at work 8 minutes before landing. Well, 9 minutes, which means that there I am waiting to find out what happened. And in about a minute or so, it would have already happened. And I did forget to breathe. So I'm sitting down there in the little selfie I took, But I did not sit down during the landing. I stood up. I jumped up and down, and at one point I thought, I'm going to pass out because I forgot to breathe. And I bent over and took a couple of breaths and then stood back up and thankfully did not pass out. So we landed, and it was about 1 p.m. our time out there. The first uplink shift, we land on Sol 0. The shift to plan Sol 1 started at 5 p.m. So we were immediately on the night shift. And who can sleep when you're going to land on Mars? So everybody that worked Sol 1, including me, but I didn't have to work much because I was Sherlock, and we certainly weren't going to do spectroscopy on Sol 1. So I got released very early in the shift, but everybody else, we landed at 1. They started their shift at 5. It was not that long of a shift, so I think they got off at 2 or 3 a.m. Okay, there's a guy I work with who's absolutely wonderful, but during Mars time, he tweeted the picture that has all the times marked out. He tweeted that because what they did to us a lot of times was they shifted our start time. So on Mars time, you want uplink to the rover every day at 9:30 Mars time, but the Mars day is longer than the Earth day. So like every day you go in anywhere from 40 minutes to 2 hours later. And so you kind of march through the night until they just decide to squeeze every ounce they can out of you, and you get stuck on midnight shifts for 4 days in a row. So anyway, his little list, as you can read it, it has his role, CIVSE, Campaign Implementations Vehicle Systems Engineer, TVSE, Tactical Vehicle Systems Engineer, off, off, off. More shifts, off, off. Look at all those offs, okay? I'm smarter than him because I used Excel. So when they changed the shift time, it was copy, paste. But there's my shifts. And you notice that, yes, I'm CISys, Campaign Implementation Systems Engineer, till Tactical Implementation Lead, Sherlock Pull, SOX Planner, Sherlock Pull, SOX Planner, Sherlock Pull, backup, CISys, till, I was doing like 5 roles. And so there's my shifts. And you can also see the start times, 7:30, 8:45. Oh, let's go back to 8:15, 8:30, 9:30, 8:30, 9:45, 10:15, and it just marches down until you get, till the middle of the night, 4 a.m., 6 a.m. It was horrible. You
remember a tweet on that big tweet that I sent you, like, I'm doing on Mars time and get coffee.
Yeah, and also the interesting thing that I had not, it's very isolating. I felt isolated because of COVID, but this was even more so because now all those little Zoom meetings and little happy hours online with your friends, they're all gone because they're still having them, but you're not because you're either working or sleeping. You have sleep during the day sometimes, and you have no idea what day of the week it is. You have no idea if it's AM or PM, but you always know what sol it is on Mars. So it was very disorienting. But if you get a little break at work, you can walk around lab in the middle of the night, which was always a lot of fun. And so here's just some of my night pictures. So this is the entrance to the building where we actually built the rover. And no, that's not right. No, that's not it. This is where we work. This is the building we work in. I told you I'm tired. So, and this is the building where Cassini did their operations. And the little NASA thing wasn't there before COVID, but it is now. And I thought it was a pretty picture. And there I'm just walking around lab, having fun, getting some exercise, and then I see the error of my ways. I turned the corner, and it was very dark, and there was this guy, and I'm like, oh no, I'm crossing the road now. So after that, every time I went for a walk, I told somebody, I'm going for a walk. If I don't come back in 20 minutes, please send someone after me. And then the question of Mars time is, what do you do with your day off when you're on Mars time? If you're lucky and your day off happens when we're, planning during the regular day, then you can go places and see things in the light. But if you're in the middle of the night shift, you can't just all of a sudden try and sleep in the middle of the night because you have to be at work tomorrow at midnight, and so you just have to stay up. So I drove to the beach to watch the sunset. I got to the beach at 2 a.m. Needless to say, no one was there. And because it's the West Coast, the sun does not come up over the water. It comes up over the marina, and so there's just a nice sunset and everything. And then I got a breakfast burrito and ate on the beach. And, you don't have to worry about COVID and social distancing because no normal human would be on the beach at 2 a.m. So, and then I like to take selfies. So this is what work looked like during COVID. So Sol 43, by the way, let Ingenuity go. That's when we dropped the helicopter. my coworkers who had been on Sol 42 were tweeting stuff about, 42, the answer to everything is us, blah, blah, blah. And so I think I tweeted to them, I said, I see you're 42. I'm going to let it go. So I made a little sign, and so that's, I wore the mask, and I had several masks, and the red mask, I got that from Stortorios. I don't think it's the same person that made the umbrella, but someone else was out there making masks, and they did a really good job with them, so we got that. And so here's what some of our rooms that we work in look like, the Dare Mighty Things, and that's the one that says Mars 2020, Dare Mighty Things. For the helicopter mission, they took down the Mars 2020 and put a helicopter up there. So that's the room where the press conference for the first helicopter occurred. They were all sitting in there. And then they also catered food because, it wasn't really safe for us to run off to get food. And when Curiosity landed, a lot of places were open 24 hours. You have the 24-hour IHOP and all that kind of stuff. Well, during COVID, nothing open 24 hours, so they catered food in. And for some reason, they kept bringing cookies. And so if you look at the picture of the kitchen, that's all cookies. There's nothing much else in that picture but cookies, but we ate them all. Well, yeah, and because they also had catered ice cream, but believe it or not, in February, when you're working in the middle of the night and you need to go, and you can't eat inside. Remember, you can't eat inside. You can't take your mask off inside. You have to go outside to eat. And it's cold. They brought little heaters, and it's very bizarre. And so no one wants to eat ice cream. But those cookies, everybody wanted to eat them. So here's one of the areas that they set up for us to go eat, and I don't know if you can see it, but there's a plexiglass. They're round tables with a big piece of plexiglass so that those tables are usually made for 4, and so we had to sit one on each side, and then they're separated, and they gave us a nice little covering because, when you're working during the day, you don't want to sit out in the sun and get too hot. And so here's the room where you can see, we see all the people. That was a shift that just ended up being all women. And so we wanted to, it wasn't planned, it's just an accident, and so we had someone take a picture of us, and we went and found someone from Downlink. He's like, oh, you want me to come be your token man? We're like, no, we want you to take our picture. So anyway, but the reason I put that there is, first of all, we look really silly. But you can also see where we work, and you see the yellow tape, the caution tape is telling you no one is allowed to sit here. And if you can see, there's also all these plexiglass things between us. And so this room is really huge where we are. And we were all distanced, and it was very bizarre. But you know what? You do what you have to do, and it was a spectacular time. And then you can see behind the one lady in the salmon-colored stuff, there's another room that's all glass. That's where the Rover planners sit. And the Rover planners are the ones that command the any motion or articulation of the arm for the rover. And they always ignored us. Even though we had a sound system like this, and we would be talking to people all over the world, the scientists would call in for tactical shifts. And we'd be like, hey, Rover planners, do you have everything you need to plan? And when are you going to be ready for reconciliation? And you'd look. And you could see them talking to each other and waving their hands. And they're ignoring you. Hey, Rover planners, can you hear me? Nothing. So somebody brought in a Nerf gun. And I was on shift when they brought it in. And I say, Rover planners, do you guys have everything you need? Nothing. Pow! Pow! And they're like, Rover planners, do you have everything you need? And they're like, yes. So I have to have fun. So I know that Insight has talked a lot about their need for dust devils because their solar panels got very, very dusty. And that's what helped out Opportunity and Spirit was dust devils would come along and clean off their solar panels. And before we even started looking for dust devils as a science thing, our post-drive images mosaics. Oh, that's an interesting thing over there for the scientists. Let's take a mosaic. Dust devils are everywhere. We still have dust devil observations, but we see them all the time. We see them in the Hazcams. We see them everywhere. And I don't know if you can see the one that's here. It's very faint. But that's one of our first dust devils that we saw. And we're like, Insight, sorry. Wish we could send them to you. So once we landed and did the helicopter mission, then we started heading south to explore the crater floor. And so you can see that the one blue thing that's where Perseverance was, and I think this is what Sol 137, if I can read, and here's Ingenuity over here. So Ingenuity started up here, and then she started hopping And so she wasn't supposed to be able to, we weren't going to allow her to fly if the rover was within 100 meters of her. We broke that on flight 3, because the scientist said, ooh, shiny, can we go a little closer? Yes, we can do that, and flight rule waiver. So, oh, and this is really cool, too. We caught this huge gust, well, for Mars, it's a huge gust of Martian dust. Yes! And we weren't imaging that, we were just taking images, and then we got this. Yeah, isn't that cool? We were very excited. And here's we're now in the Green Zone campaign. This is our first campaign where we're exploring a region of interest using all their buzzwords. And so we landed here, and then we're splunking down here. And this area in here, where you see it says Seitah N, Seitah S, so that's Seitah North and Seitah South. So that's an area that we really can't drive the rover, but it is very interesting to the scientists. And so you can see the reason that we go around, so there, it says 3 forks up there. So that everything in the middle of that we can't drive over. So if we wanted to go straight to the delta, we wouldn't be able to do that. So we headed south because it looked interesting to the scientists. And this CFFR, crater floor fractured rough, that's what they started calling this because they don't do as many outreach talks to normal humans as I do. Otherwise they would have called it like Sam. But so anyway, so they wanted this to be their first area that they were going to do a sampling. And they were very interested in Seitah, and so they planned to come down to the south, go around the edge, and do this toe dip at Seitah South. But we weren't not really sure if we could take the rover there. So here's a Flight 9 from Ingenuity, and you can see her path for Flight 9. This was a 625-meter flight. At that point, the rover had not driven 625 meters. So for a brief, shiny moment, Ingenuity had gone further than the rover. We've caught her. We're at 2.2 kilometers now. So if she keeps flying, she's going to get ahead of us again. And the black and white is the Navcams from the image. So that's just looking down from the helicopter as she flies over Seitah. And then I don't know how long this takes, but at some point she'll land, and then we have to figure out exactly where she was. But also, when we first started flying the helicopter, there's all these rules about there's a helicopter base station on the rover, and that's how we communicate with the helicopter. And there's all these rules about the base station has to be pointed towards Ingenuity. Ingenuity doesn't care. She can talk to us no matter where we are, it seems. She's fabulous. So I'm going to move on from that. And so here's the good image, the pretty color image from Seitah from the Air. And so at first the scientists were like, we have to sit around and wait to do science for 30 sols while you fly this helicopter. Because they've waited years. They spent years, over a decade, working on their instrument, getting their instrument on a rover, getting it to Mars, and now they have to wait for a helicopter. But then when they figured out the helicopter can go and look at stuff for us, they were much more supportive of the helicopter. And so at this point is really when Ingenuity went from a technology demonstration to an operations demonstration. So we're trying to prove, and we have, that the helicopter is very useful and can work very well with the rover. And so me and Farah Alabai were the main people who were like given over to the helicopter. We were the main interfaces into the system and the operations of the rover. And so me and her did a lot of work. She did a lot more than I did. And so there's where we're driving, and the scientists look way ahead, and crater floor fractured rough. And so they pick this area, and this is where they want to go to try our first sample, because we need to bring those samples back. So to do the first sample, we have to first test all the systems. And one thing that we have to do is we have to sort of plug into the rover and change out the bit that's on the rover to pick up the drilling bit that has the sample tube inside it. And so there's that actually happening on Mars. That was terrifying. And then we had a witness tube that we wanted to go ahead and seal. First of all, to prove that we could seal the tube, and the whole thing with the witness tube was to tell us what kind of contaminations had gotten into the system before we started sampling. So we have basically sealed an empty tube. So those images there are from the cache cam, and then we put the seal, and then we heat it up to like 50 C, and then it's sealed. And so now we have a sample that's safe to bring back to Earth. And so we get to the area where we're going to do our first sample, and Zcam takes wonderful images, and we're down at CFFR. But first we're going to fly Ingenuity again. So if you see those raised bridges down at the bottom, they were very interesting to the scientists. So we send our helicopter down to look. And this is what she sends us back. And everything in there looks tiny, but it's not really. When we got actually a little closer, it looked a lot bigger. I'm like, that's just crazy. So then shortly after that, we found a rock in the same area, and we decided to do our first abrade, and we're going to do a sample here. So this is our first abrade, where we take our abrade bit on the end of the drill, and we just kind of grind down the surface, sort of like the rat on Opportunity. And what we're trying to do here is we're trying to make a flat surface, because Pixel and Sherlock work better on flat surfaces that don't have any dust. So we abrade, and then we use our dust removal tool, which is, we call it dirt, because it's a gas dust removal tool, and we go and get rid of all the dust. And then put the arm down. We do, what are you doing to me? Try that again. Put that down, and then we use our Sherlock, well, this is from Watson because it's color, and so you can see that there's a bunch of like divots taken out of this. So that was our first clue that this was not the most stable rock that we should be sampling. But we press on, and we do Sherlock. This is a Sherlock image, and there's the abrade bit that did that for us. And then now we've named this Roubion, our target, and we've drilled. This is our first sample attempt. And one day, we commanded the rover to go down, sample, bring the sample inside, and completely process it, and then we'll see what we get. And the next day, that was a management decision. But anyway, the next day we get this image. It's one of the highest priority images, so it's one of the first images we get down, and what it shows us is a sample tube that is sealed. We were very happy. We celebrated. We jumped up and down. Then we got that image. Cash cam of an empty sample tube. So the atmospheric scientists for years have been asking us, can you please make one sample tube just empty so that we can have a sample of the atmosphere? And they were told no, in no uncertain terms, never. Ta-dun! They have it. But the question was, where did the sample go? Well, it's not in the hole. And we looked all around the rover, it was nowhere. And so if you look at this hole, though, and here's an even better shot, we shot the side of the hole with Supercam, you can see this is just mainly dirt. And so we have either drilled into a rock that was super crumbly or that was super thin, and we just got dirt, which meant that there was no sample, because the sample tubes are made to have solid samples, and if it's just dirt, it's going to fall out. So that was our first, that was very sad. And then it always makes us feel better to fly Ingenuity, so we sent Ingenuity off to look at South Seitah, and again, she found the rover when she's not looking for it. So the green here is where all Ingenuity's been, and the white is Perseverance. And now we're going to do a second sample because we've done a lot of work, and we're going to do ground in the loop like we should have done in the first place. And we find a much better rock. That's a beautiful rock. And it gets a new name, Rochette. Beautiful rock, looks solid. I think we should sample. So we abrade first because we want to have the Sherlock and pixel data. The abrade, beautiful. So when you look at the first, Guillaumes was the first sample, the first abrade, and Bellegarde was the second. Bellegarde looks like a much more hard, sturdy rock that can withstand sampling. And this is a Sherlock image, and Sherlock does a 7 millimeter by 7 millimeter little postage stamp array of laser shots, and so we always take an image so that we can figure out exactly where in that little hole that we ended up. And then we core. So this happened, so this was planned before I came to DragonCon, but because we're in what's called restricted, where Mars is so far ahead of us that when we plan a day, like I planned on Wednesday, and that didn't actually go up until Thursday afternoon. So it took us a while to get the data. So while I'm waiting to fly to DragonCon, we get this image, and this is our drill with the sample tube in the middle and an obvious piece of rock core sitting in the middle. Then we took more images, and they said maybe it's not really there. Now we have millions of images that show yes, it's a real rock. And so sometime the next day we're going to pull that inside the rover and seal that sample tube, and then we're actually gonna maybe do a second sampling at the same site, but I don't think that's been decided yet. So anyway, woohoo! So that means that Mars sample return project doesn't have to be canceled because we can actually sample. Woohoo! All right, that's my really quick run through of what we've been up to. So, woo! And I left 12 minutes for questions. So if you have any questions, I will try to answer them.
So, something that crossed my mind when that first sample didn't work. Check, check, check. There we go.
Woo!
Something that crossed my mind when that first sample didn't work. How many shots at sampling do you have before you just run out of tubes?
Well, we have 42 tubes originally, and so I think the prime mission goal is to have 20 samples, and prime mission is two Earth years, 1 Mars year, and so, but I think 2 of the tubes were supposed to be witness tubes, so we took the first witness tube, and then somewhere in the middle of the mission we'll do the second one. But now we have an atmospheric sample. And by the time I get back to JPL, we'll have a real sample, and that'll be awesome. Yes?
So you mentioned dust devils before. Have you seen Ingenuity encounter any dust devils or like wind events while in flight?
Well, she has encountered turbulence and weird occurrences, and the coolest thing, and I only had so many slides I could put in there, is that in some of the images, they process them in a way that you can actually see all the dust kicked up by the rotor blades. And she just did her 13th flight, and there was part of that where they were doing special imaging by Mastcam Z to really see the interaction of the blades with the dust and how the dust kicks up, and just because they think that will tell them more about the wind, how the wind is on Mars. And so whenever Ingenuity is flying, we have META, because it has 2 wind sensors. We always have META on during the Ingenuity flight so we can get all the wind data. And in the beginning of the mission, before Ingenuity started flying, META had been marked sick because it just happens. And they were trying to figure out exactly what was going on with META. And so for a few sols, we couldn't have META, and the Ingenuity team was like, we need the wind data, we need the wind data, we need the wind data. And then, of course, META people figured out what was going on, and we were able to successfully turn META back on and keep going, so.
So I don't remember if it was like a sensor data discrepancy or like a coding error, but how did you feel when Ingenuity had that little crisis where it kind of like jostled on one of its flights? And
Oh, well, yeah, we didn't know anything about that. We were just told later that they report out. Yeah,
like how you reacted to that. Like
oh, well, well, it was already okay, so we were quite good. But what got us was when we first did the high-speed spin. We did a low speed, when we first dropped off Ingenuity, we didn't just start flying her. We released the blades because they had been locked into place for a launch and landing. And so we released them and we got a video of them going. And then we did a blade wiggle because her blades can do this. And so then we did a blade wiggle. And then we spun them really slow. And then we did the first high speed spin where we're going to spin them at 25,000 RPMs. And she said, nope, no, absolutely not. And so that's when we all panicked. But then they figured that out, and so a couple of the flights, their workaround was going to work like 85% of the time or 75% of the time. And so flight 4, which I planned, did not execute. And so then we eventually updated her flight software, and so we don't have that problem anymore. But that was more concerning than her little wobbling, because that was later. She'd already done everything that she was really set out to do.
When you're... Oh, hello? Okay, there we go.
Go ahead.
When you're like issuing commands to the rover or driving it and operating it, about how much actual delay is there between issuing commands to it and it coming back and confirming that what you wanted it to do actually did happen for you to do the next steps?
Well, what we do is we don't sit around and wait. Usually we send the commands at like 9:30 a.m. her time on Mars. And then those commands tell her what to do with herself for the whole next 24 hours, the whole next day. And then, so the juicy spot for the scientists and for driving is early in the day. And so somewhere around 4 or 5 p.m. Mars time, we'll have what's called our decisional pass. And when we get that data, then we start planning the next day. And so after she gives us the decisional data, she's still doing stuff. She's still doing observations. And so we don't joystick the rover. And when we have ground in the loop, usually it's a whole day. Like when we were releasing Ingenuity, we commanded Ingenuity to do one thing, the drop, and it would go down. And then the rover would do other things, like remote science, SuperCam and MassCam Z and Meta, and then we would just the next day then command the next step. So it's usually a whole day before we can respond to anything. Yes?
So on your most optimistic day, 10 centimeters by 10 meter hole in Mars robotically or with human assist, how far out is that? To drill a borehole.
To do what? To drill a borehole?
A borehole, yeah, for thermal storage, but that doesn't matter. Just physically going 10 centimeters down 10 meters with a robot or with a person.
They tried that with Insight.
Oh yeah, but that was not
that
a
was
real
different.
drill.
Yeah, I'm not sure. The whole thing with the humans
Years,
and stuff.
decades, or centuries?
Well, it's like anything else that we try and do. It depends on how much money you put behind it. If you put a whole ton of money, you're still at least a decade out. And if you don't put a whole ton of money, you're probably 20 or 30 years out. So
the crazy guy with the starship, and he's going to go there way before everybody says we will. So if people were there, and then
I do robotic exploration because I really like staying on Earth.
What would be a worst case scenario? Like, what was your biggest fear of things that could go wrong?
Well, oh, wow. Okay, explode on launch was number 1. Make a really big crater on Mars was number 2.
Mars observer.
Yeah, and so after that, when the first sampling failed, and those of us who have done several rovers now, we all know, because, I think it was a press release. I can't remember if it was a person that said it or that it was in the press release that was written. We tested the drill, 300 times on Earth and it never did that. And I'm like, yeah, welcome to Mars. Mars always surprises us. Mars always gives us challenges. But, we do our best to find a workaround. And I do not work on the sampling team, even though I think someone tweeted I was an important member of the sampling team. The sampling lead did that because I plan their stuff. I help them out, but I'm not on their team. But I knew them, and they're all very smart people, and they worked very hard, and I knew we would find a way to fix it if it was fixable, if it's not a hardware failure, or if there's not a flaw in the system that just cannot be worked around. And so, but yeah, my biggest fear was, yes, explode at launch or crash into Mars on landing. So I'm doing good.
Is there any data on chemical analysis of the amount of perchlorates in the soil and or rocks?
That's very interesting you asked that. I think that when AGU happens, you'll be a very happy man. So a lot of the science results have not been released yet because the scientists like to be published. And the American Geophysical Union meeting is happening, I think, in December. And there is a whole session devoted to Mars 2020. And so I know that Sherlock's seen some really cool stuff that I don't absolutely understand at all. And they're working very hard with Pixel because we finally have Pixel and Sherlock on the same area for both Abrade spots. And so there's a lot of work that the scientists are doing to, say, we saw this, you saw that, what does it all mean? And so everybody's working really hard right now. But that subject just came up the other day, so there's going to be something about it.
What's the absolute coolest part of your job besides all of it?
Okay, you're going to think I'm schmoozing, but coming and talking to you guys is the coolest part of my job. So yeah, because I'm excited about it. The people I work with are excited about it, and that I get to come and talk to you guys is just a gift. Because, when I was growing up, this is what I always wanted to do. I always wanted to work on some sort of spacecraft and everything. I never thought about a Mars rover because they didn't exist back then, but it's really cool. I know one day at work we were having, some days go well, some days don't go as well, and at the end of the day, one of the last things we do when we're planning for the rover is we do what we call integrated modeling and validation. So we take everybody's sequences that they've written, we put them through this simulator, and then it spits out stuff to us like it had actually happened on Mars. And we had a failure in the arm backbone, in the modeling. And then again, another failure, and it was getting really late. We've been there a long time. uplink, the time when you have to send these sequences up to the rover, was getting really close. And if you pass that time, you're just done. That plan that you've worked these 12 hours on is never going to Mars. They have to start over the next day. And so we got the results of the modeling, and I looked through it, and I was like, it was really late. Everybody was really tired and grumpy. And I'm like, this looks good. I feel good about this. I feel good. How do you feel, mission manager? I'm feeling like this is it. This is the one. And he's like, I feel okay, Kim. And then so I got up and I went over to the rover planners, because they're the ones that have to confirm that everything was okay with the arm backbone so that we can go to the next step, which is bundling everything up and flinging it into the rover. And so Camden was over there, and I'm like, Camden, tell me. Talk to me, Camden. Tell me you see the woohoo. And because they have an EVR, an event record, that tells them it's successful. And they call that the woohoo. And he's like, I'm looking, Kim, I'm looking. It's going to be here, I know, it's going to be here. And he saw it, he goes, woohoo, and I yelled, I screamed, woohoo! And then I said, it's a good day to be working on Mars. And then I went and sat back down, and the mission manager's like, I appreciate your enthusiasm, Kim. And then I said, I hope everyone else does. But by that time, everyone was awake. It was really late. Everyone was awake. Everyone was like, yes, we can do this, Kim. Yeah, and in 20 minutes we were going home, because everything was done, and it went up to the rover, and it worked fantastic. That was Pixel, our first Pixel. So, one more question?
Yeah, small thing, but Mars time question. When you mentioned 9 o'clock on Mars or 5:30 on Mars, how do you label those extra 40 minutes that don't, given that it's 24 hours?
Well, our tools have Mars seconds instead of Earth seconds.
It's just slightly longer?
Yeah. And so it's funny because our tools, some tools work in Earth seconds, some tools work in Mars seconds, and then they do the conversion. And so sometimes you think something should happen at 12:45:04, but in the modeling it's 12:45:05. And so, if you think about it too hard, your brain explodes. So, okay, I think it's 9:30. Do you have one more?
What are the upcoming interesting things to look at?
Well, my goodness, I think the sealed sample tube is going to be the most interesting thing that will come up yet with next. Where's the next sampling going to be? And where is Ingenuity going? I think that's it. So, woohoo! Thanks! I already gave it to you. When I said you had to go, I gave you both.
Thank you.
So thank you again for coming to see me. I really appreciate it. I know there's lots to do at DragonCon, and thank you.